And hi everyone, good evening. I hope all of you are having a wonderful weekend. Um, I hope are your exams over or still like scheduled for later? How is it? Are scheduled for later. Okay. So before we get into Arduino and the whole today's topic, I want to ask you a question on how different it is from school to college. So when we started learning in school, we had like a lot of practical based learning. If you remember, we were introduced to magnets and chemistry lab in 9th standard. And I still remember if I keep any copper salt in front of Bunsen burner, the Bunsen burner will turn blue. And similarly, magnets, even though I don't clearly remember what is the direction in which the field was flowing, but I remember the shape of the field, right? Do you remember something like that from engineering, like so specifically and so brilliantly? I guess no. I mean, at least I don't. So let's look at a small poll. How is Indian engineering education? How much do you like your current education scenario in Indian engineering? In India, one second. Yeah, in Indian engineering scenario, do you like it very much? Are you happy with whatever you're learning? Yes. Yeah, you prefer to have most of you do come to like option 2 or 3, right? You are not happy with just theory concepts that you learn every day in college, where they just teach over and over again the same things that you already like, mostly in theory format, right? Okay, that's wonderful, guys. Thank you so much. Okay, so let's get. I am Pujita. I am from Sapiensity. So who are we? Like, what is Sapiensity? We are an tech startup that's helping BE engineers become truly incredible engineers instead of just degree holders. Why am I saying this statement? Let me start off by giving you a shocking fact. According to National Employability Report of 2019, India is the largest producer of engineers with 3.8 million students graduating every year. That's 40 lakh students graduating engineering every year. And even though you consider 50% of them are of circuit branches, EC, CS, IS, and EEE and all of that. So you have similar electives, right? So even if you consider them, around 20 lakh people are studying the same subjects as you study every single day. So where are we going with these 20 lakh people, right? 80% of them are not even fit for engineering level jobs, are not unemployable. It's a little too extreme. But the point is they're not working whatever we learn in engineering, like the kind of problem solving that we do, the kind of knowledge that we learn in 4 years of engineering is not being put to use completely in the job that they're doing. It begs us the question if Bachelor's of Engineering is really a professional degree or just a mere certificate of participation. The biggest problem in Indian engineering institutions is that it does not provide students with adequate opportunity. It does give you a number of opportunities. For people who are looking out for opportunities, there's a lot of opportunities for you to go up and grab there and learn more. For people who are a little more underconfident of themselves and not very sure of what to do, they don't have adequate opportunities for experiential learning, study skill development, or industry coherent knowledge, leading to poor career readiness. Here's the root cause. Engineering students are somewhere failing to evolve as capable engineers due to lack of experiential learning and continuous skill development. Today, when industries are looking for people when technology is changing every minute, industries are not looking for people who know a lot of skills, but are looking for people who can put a certain skill to apply and solve a world issue, right? Like real world problem. So I spoke about experiential learning. Yeah, participation certificate for sure. Yeah, so I spoke about experiential learning. What exactly is experiential learning and how is it different from the normal learning that you do? Experiential learning is a method of learning by doing. It is distinct from traditional methodology, which is passive one-way communication and rote methodology, and thus making it a cycle. How's it a cycle? You learn something, you apply the same knowledge to complete a project, to complete an activity. And in that process of doing that activity, you learn a lot more. So let's take an example. In first years, all of you had /n and /t, right? Computer science, you have all learned C programming. And your teacher exposed you to, like, she made you understand what was /n and what was /t in class. And did you completely understand it? No, you were like, oh, what is the line size then? How can I give like 2 lines? and you were fascinated by what backslash did, right? Like if you put two slashes and one, you had to put two slashes to put one inverted comma after there to not mistake it for a character, right? And print it as it is. So it was very fascinating. But did you all remember it when the teacher taught you? No, right? You went to lab, you experimented it, you saw what happens if you put single slash and apostrophe, and or if you don't put slash at all, what happens? All that you did, and understood what exactly it means to have slash and slash t. And even today, if somebody asks you, you are in a position to answer it because you did an activity with it and you understood what else does these results imply and how do I make changes with these results to improve my learning. Okay, why are we talking about? Let's take more simpler example, a more nominal example that one would have had in their lives. Say, suppose you're starting to cook, and the first thing you learn is to make coffee. So in that process of making coffee, you initially start off with, say, reading a book of like recipes, how to do coffee, or you go to your mom who's like making coffee, you look at it. And not exactly when you start cooking or like when you start making coffee, you don't really follow the instructions in the book. Like if it says 1 tablespoon of coffee powder, 1 teaspoon of sugar, honestly, I don't know what is tablespoon and teaspoon. I don't follow it. And your mom also puts like 1 spoon or like 2 spoons. You'd be like, I don't like this. I don't want this much coffee powder. So you experimented with it. You put 1 spoon, you realize it's too much. You reduce the quantity, you realize it's too less. By third, fourth or fifth day, you arrive at your optimum quantity of a nice coffee that you are happy with, right? And what do you do next? You make it restaurant quality, right? You want to put it to Instagram story, show it to the world that you know this. Come on, we all did dalgona coffee in 2020, right? Same thing. So you put on top, you put cinnamon powder, you sprinkle some coffee powder on top just to make it look more pretty. You froth it, all that you do. And by 11th or 12th day, you arrive at your perfect coffee recipe. That's your recipe. You have made it your own. And your mom wants a cup of coffee from your hand because she loves it. Imagine a lady who spent 20 years of her life in kitchen, making coffee for herself, others, you. She wants coffee from you because she likes it more. How much have you come so far from like taking, reading recipe book or looking at your mom making coffee to today where you're making restaurant quality coffee, right? How much have you learned and improved? Imagine if you could apply the same philosophy to anything that you learn, one subject, or let go one subject, one module that you learn in your college. Imagine if you could apply the same principle, and how much would your learning improve, right? Significantly, right? More people also wants to join. I'm not sure how that can be accommodated because we have like just the basic premium account of Zoom. So if something else can be done, I'm not sure. Right? So it's not just watching and watching, it's watching, building and learning, thus making it a cycle. Watch here can refer to videos and resources that you want to use or learn to, like you use or learn, like using that you learn, right? So I got distracted. Okay, why are we talking about experiential learning in an Arduino webinar? Why am I talking about it? Why am I stressing so much on experiential learning when I'm supposed to talk about Arduino? If you don't think that they're related, they are definitely related. Arduino is a classic example of this learning cycle. How do you ask? Development boards are found everywhere today. Something mechanical, you want to make it automated, you can use a development board. You don't believe me? Let's take examples. You want an automatic lighting system, you can use a development board. The thing that is right in front of you right now, your phone, your laptop, has a development board. You want to send something to Mars, you use a development board. Fun fact, Mars, the recent Mars rover that went has a microcontroller chip. It has a lot of chips. It have a lot of microcontroller chips, a lot of development boards, which makes it if you want to Vijay, can you like let me know what can be done, because we actually have only this premium account of Zoom. We can't actually
unfortunately,
have.
this is the limit. We should continue the session. For those who couldn't, the recording will be shared on YouTube. You could watch there. So Yeah, we can continue.
Thank you. Okay, so when you use the Mars rover that went up recently has a lot of microcontroller chips inside, has a lot of development board inside, right, to help it function. So in that, one of the chips were produced by a company called Atmel, and that's the same company that produces Arduino also. That's a nice fun fact. And you want to fly drones, you should use a development board. So you see, your AC, your refrigerators, your microwave ovens, everything have some kind of microcontroller chip in them to help them make those tasks more better and more automated. Even those remotes that you have today, smart TV remotes, smart TVs, all of them have some kind of microcontroller chip in them. So you see, any mechanical action that you want to automate it, you can do it with a development board. Okay, let's understand what is a development board. So consider a smart lighting system at home. Most of you, like the newly built home, will have this kind of lights already. My friend used to have this like automatic lighting where you go in and the light turns on and you roam around and the light keeps on, and you come out sufficient in activity, the light turns off. But the problem was it was there in that kitchen. Okay, so when her mom used to sit to cut vegetables, she used to sit idly. So it used to detect that there's no motion and turn off the lights. So disadvantages of technology, but it's a great thing. No, dad won't come and scold. So we won't get that scolding. So it's good. So when people are inside the room, the light gets on. When there's nobody inside the room, the light gets off. So here you need to make this kind of structure. So when you take something, when somebody is roaming, that is detected by a sensor. There's some motion detected, and this is given as input to a development board. And this development board analyzes this input and then gives a command to the light saying, hey, somebody entered. If there's no motion detected, a certain value in the sensor threshold is crossed. Like say, when somebody is walking, it's +1. When nobody's walking, it's -1. Simple digital terms. So the development board detects if it's greater than 1 and says, okay, that it's greater than 1, so somebody is roaming around. And once it is less than 1, it will say, okay, there's nobody roaming around, so to turn off the light. So it will tell the light to turn off, saying, oh boss, there's nobody roaming around, please turn it off. Simple, right? So for this, this development board, the input-output board, the memory, and the processor, everything is put into one single circuit board, and this enables you to build any kind of real-world system. And this acts as a brain of your system to understand what it should be done, what is the input, what should be the output, what should be the command given to the components that it is connected to. Sounds interesting, right? Now, there are many different kinds of development boards today in the world, right? You have Pico, you have Raspberry Pi, you have Arduino. Why specifically learn Arduino? Why should Arduino be my first development board that I learn in my engineering? Why shouldn't I learn Raspberry Pi? Why shouldn't I learn Pico? Why should I learn Arduino first? However, Arduino is not just a development board. Arduino is an open source platform that provides us easy to use development boards along with open source software programming. It's one of the most popular boards used by students and hobbyists all around the world and has created a revolution in terms of open hardware. Millions of students today are easily able to convert their dreams and ideas into real-world projects with the invention of Arduino. Arduino is so popular, not just because of its development board, but its whole ecosystem of open source hardware, software, and this global community that backs it up every single day. Okay, so that's interesting. I am convinced that Arduino, yeah, it detects ghosts also. Of course it does. So you can, okay, Arduino is so popular and interesting. Where can I learn Arduino? Where can I learn Arduino? You can do a self-planning and self-learning on YouTube. We all know how that will go. If you're very disciplined and very nice person and a very disciplined person, I don't know who you are, but it's very good. You can do it on YouTube, but people like me, please don't do it on YouTube, because you can start with an Arduino video and end up watching, for me, it's some Harry Potter explanation videos. So for you, it'll be different. You all know what that is. So yeah, we can't do that. So even if you say, okay, I'll learn it in incognito mode, the problem with YouTube videos is Some of them, this Arduino is such an open source and so widely used that there are so many resources out there, so many videos that already have the required information and all the things that you need to learn Arduino. But the problem is there are a lot of videos that are connected. Some people do make a playlist of them. And if you find a good playlist, then amazing, you can learn it there. But say you don't find a good playlist, what happens? So you're watching a video that is 12 minutes long of some XYZ channel. You watched it, and then the second video, you get an 8-minute video of ABC channel. You jump into that 8-minute video, you realize the last 4 minutes of this 12-minute video is the repetition of this 8-minute video. So you think that it's a new concept. I'm happy I'm repeating it. But no, you're not, because you already learned it. You already would have made notes. You already would have registered it in your head. So it's just time waste. You're just watching and watching all over again the same thing that you have already learned. So the second method is self-paced online learning, which you can do Coursera, Udemy. The price range is from 3,000 to 10,000 without the Arduino components. It's a little expensive. So Arduino community is an open source community which has a lot of resources, a number of resources just for you on their website. We'll talk about their website later on. And you can learn it from us. We have Daika from Sapiens. We have an extensive course that has both online and offline experience just for you. Okay, that's about the course. And where can you get the components? You can get it at a store nearby if you're like socially awkward like me and do not absolutely hate human interaction. Then that option is not at all for you. Don't even consider it. Then you have online stores. There are multiple stores that sell you Arduino specifically. Arduino and Arduino related components. There are lot of digital platforms, digital component selling platforms that you can buy from, or even Flipkart, Amazon has a number of starter kits for you, price ranging from 2,000 to just the Arduino board will cost you around 800 to 1,000 depending on where you're buying it from. But the problem is you can't just use the Arduino board, right? You need the sensor, you need an output device, say an LED or a buzzer or like a motor, all that you need, right? So for those, everything you need a starter kit. You can't buy everything separately. So it's important to buy a starter kit. So in those starter kits, the price range is from 2,000 to 10,000. You have a number of things that do not even have 20 components inside them. We have Daika from Sapiens. We have 30 plus components that's enough for you to set up a small lab at home. Okay, let's see Daika. Why Daika is best for you? Under a minute, we have Watch and Learn and Build and Learn. For Watch and Learn, we have courses that are bite-sized that have 100 minutes of videos, interactive videos and quizzes. For Build and Learn, we have an Arduino starter kit that you can set up your own lab and work hands-on. We have 30 plus components inside, and we have a beautiful box where you can carry around your components together. Like it's a very nice box and 30 box where you can carry around your digital components, because it's difficult to carry those wires inside your bag, right? You need a container. So that container is nice. I'm just saying. So yeah, you have 30 plus components inside of it. Now let's get back to Arduino. The Arduino ecosystem. I spoke about Arduino ecosystem. They're made of many different things. Let's look at them one by one. Yeah, let's look at them one by one. Firstly, the Arduino boards. Arduino provides us with easy to use hardware. This microcontroller based board, which acts as the brain of our system. We already know this. But way back in 2005, there was only one board, but today we have many different kinds of boards, such as they differ on processing speed, input-output interface, power consumption, size, and of course, pricing. Few examples are Arduino Uno, which is the most popular one, and Arduino Nano, Arduino Mega, etc. Now we have the Arduino component. We just realized that Arduino just is the brain of the system, right? So we need something that is the body of the system. So you need components. So those components are initially connected to Arduino through jumper wires, or like soldered for more permanent circuits. That's not a prototype. And using breadboards, you can make it more organized and beautiful. The circuit looks better. You can use a number of sensors for different functionalities. For example, we just saw the smart light system, right? So for that, you need a sensor that detects motion. So for that, you can use a PIR sensor or IR sensor. There is something called humidity sensors that you can use, DHT11, which you can use, which records temperature and humidity for this purpose. Say you want to build a weather forecasting system where you will tell if the humidity and temperature are of this limit, then you will be like, okay, it might rain or it won't rain, don't go fishing, and all of that. So you can do that with THT11 sensor and an LCD screen connected to Arduino. Program it however you want. So let's talk a little more about Arduino boards. As previously mentioned, this is the brain of the project, and it can perform these logical operations because of this microcontroller present in it. This is Atmega 328P microcontroller produced by a company called Atmel. Okay, so input-output ports, you have digital ports, you have analog ports. Analogs are usually output ports. Analog are input ports that accept the output from the sensor, and digital pins can act as output or input depending on how you want to program it. TX and RX LEDs, transmission and receiving LEDs, they blink when you're transmitting, they blink when you're receiving. Reset switch, this is where you will be dumping your code, right? When you connect USB here, you will dump the code into Arduino, and that will run with the help of this. So when you press the reset switch, the code will be trashed and like the code will be discarded. And you have power port. So what is the output of Arduino? You can see here it's 3.3 to 5 volts. That's the output range of Arduino. So you should not connect something greater than 7 volts to this Arduino as input. So if you connect it using a USB, then no problem. Your system will not give output more than 5 volts. So it's not a problem. But if you're connecting a power port, if you're connecting it to power port directly with the battery, then you should take utmost care to not connect something greater than 7 to 9 volts. Even if you do, there is a superhero to save it, voltage regulator. But the problem here is this is a digital circuit, and all of us know any digital circuit should not be given power greater than 20 volts. So even in the worst case scenario, you have to give something power that is greater than 9 volts. Please do not exceed 20 volts. Because there's a high chance that you might damage some of the components inside and the whole Arduino board will be destroyed. So you all know as engineering students that what is the thumb rule for digital circuits. So yeah, and voltage regulator, I think everything we covered, right? That's it. So it has power supply, ground pins, basically a mini computer that you can use to perform a certain task for you with the help of components it is connected to. Next is the software, which is called the Integrated Development Environment, or IDE. You already know, if you are familiar with Java, and if you have learned, if you've heard about Java or like just explored a little bit about Java, you already know what is IDE. So this is the software tool that is used to create an Arduino program and upload it to the board. You can communicate to the board and from the board to yourself. You can communicate both ways. So consider the same smart lighting project. For this, you need a sensor that recognizes when you enter the room and gives input to the board saying, hey, someone entered the room, right? And once there's nobody in this room, you should tell, okay, there's nobody in the room, you can turn it off. But it's not going to do the task on its own, right? Even any digital circuit or anything that you have currently in front of you, phones, your laptop, they do not do the task on their own. You have to tell them, specify the task that you want it to do, then only it will be done. Right? Similarly, for Arduino, you have to instruct the board to perform this task. How? By you programming these instructions into using a coding language on software that runs on this computer. This software that runs on the computer and delivers the program to Arduino is called Arduino IDE. And development boards can be programmed using C, C++, Java, or Python, depending on the development board. Today, programming has become such an important aspect of being an engineer. Every engineer today needs to know a programming language in order to like survive in this ever-changing world, right? So how is Arduino coded? It's coded using Arduino language. I always thought it can be less, it could have been less simpler, like less direct, but it's okay. This is the programming language that is used to type the codes on IDE. It's built on C programming, and honestly, C programming is one of the best programming, like easiest programming language that is out there for beginners. We've all learned it in first year. We all know what, of course, you go up the complexity pointers, you get hundreds of segmentation calls, it's okay. But until function structures, it's beautiful, right? We know print statements, scan statements, we know for loop, while loop, if statements, and then we come back to structures, right? All that is so simple and so nice and user-friendly. Lastly, we have a vast and powerful Arduino community, all seeing the power of open source. Today in this world, half of the programming softwares or languages that are there are open source. Python, Linux, There are a lot of applications that are open source, MySQL, MongoDB to a certain extent, it's still free to use, right? Some of them are not, like some parts of it is not, but still. So you see the power of open source today is what is driving the world. Whatever the most powerful softwares out there are open source. TensorFlow, Kaggle, the data set that you use for your machine learning algorithms, all of them are open source. So that's one of the reasons why Arduino is thriving and surviving for so long, because of its wonderful community. They have a beautiful, extensive website there you can buy an Arduino, learn Arduino, donate to the community, interact with the community. There are webinars that are conducted to constant betterment. You can buy starter kits. You can like talk in the discussion forums. You can do a lot of things. Look at that website. It's so beautiful. Even though UI is not that friendly, but it has so much information. You can learn Arduino from there for free, right? Okay, so let's look at simulations. So this is Tinkercad. Again, Tinkercad is open source and free to use. You can go to just type Tinkercad and you will find a lot of resources that helps you to understand Tinkercad, to do stuff on Tinkercad. So you can log in through Google or create an account just for you. So 3D designs are something that are very important to mechanical people if you have mechanical seniors. And yeah, something that we are interested in today is circuits. So let's look at a very basic circuit and how actually the Tinkercad dashboard looks. Okay. I won't be explaining analog and PWM in this. It's not something that we'll cover today. If you have any specific questions about it, you can do ask. Arduino is not a club or society. If you're asking about in your college, I think Vijay will answer it better. I hope all of you are having fun. I hope something is interesting and nice. Yeah, I think somebody has suggested where you can buy also. That's nice. Okay, so this is the basic circuit for Arduino. This circuit, don't worry. Like Tinkercad is so beginner friendly, and they have a lot of starter circuits that you can use. We used a breadboard to make, as I told you, breadboards are used to organize the circuits better and to make the circuit look more presentable. So on the right, you have components. You know a lot of these: resistor, LED, push button, potentiometer, capacitor, batteries, and breadboards, Arduino Uno, then vibration motor, DC motors, servo motors. If you don't know what servo motors are, they just wobble, they just move around like some door closing and opening types. And RGB LED, these are very beautiful things. You change the voltage, the color changes, beautiful there. NPN transistor, you already know, diode, photoresistor are they change the resistance value based on the light that is given to them. And ultrasonic sensors works based on principle of sonar. You can calculate the distance. PIR sensor detects motion. Piezo is kind of like a buzzer that emits a certain tone. Temperature sensor detects temperature straight away. And this is a multimeter. Okay, so here components, you can go to circuit assemblies, Arduino starters. And when you go, you see a basic breadboard circuit and you see a blink here. And here also you can see the pin 13 is connected to this side of the LED, that is anode of the LED, and the cathode is connected to the ground. But I've connected it here in the ground because it's easier. It just looks like the circuit is circle, right? That's what we've learned. Circuits are circle. So here also it's like circle only, but I wanted to use the breadboard, so that's why I've taken it here. This is the same circuit that I've used and put it here. So yeah, so you have a number of circuits that you can use directly from here and understand how they work and construct your own circuit. So you have fade LED, button LED, debound, state change. You can see all of these, what do they signify and how do they work, and half of your Arduino knowledge is already done. And using this, you can build a real life prototype, a real life solution that you want to build for any other any practical problem that we'll actually see in this session. So this is how it looks. So let's look at the code. So void setup, these two are functions, you already know. This also looks like function. These are also functions. So every line here is a function. There's no variables. Everything is a default function. They're already defined in the Arduino IDE library that you can directly pick and use. So pin mode, you're setting the LED built-in to the output. There's this LED built-in that is the output, and that is connected to pin number 13 directly. So this LED is set as output. So this also will be set as output. And then you're digitally writing the LED built-in to be high. You're waiting for a second. This is in milliseconds, so you're waiting for 1 second, and digitally writing the LED built-in to be low, and again waiting for 1 second. So if we're thinking that this will work for 1 second turn on, 1 second turn off, 1 second turn on, 1 second turn off. That's what we're looking at. So let's see if it works the same way. Yes, it does. So it turns on here also, and it turns on here also. You should know why have I connected a resistor here. If you do not know, I'll explain it to you. So the maximum voltage that you have to connect to an LED is 1.2. You should not connect something greater than 1.2 to any LED. So, but the Arduino output is 5 or 3.3, which is pretty high compared to 1.2. So you will attach a resistor so that the voltage drop across the LED does not exceed the value that you think should not exceed. Okay. So what happens if it exceeds? The LED will like burst. You can actually, don't try that out in your lab, try it out on ThinkPad. Definitely don't try it out in your lab. Your teacher will be furious. So yeah. Okay. So what is the next step? This is like the print statement, right? What did you learn after print statement? Oh, I forgot to tell you one thing. Yeah, so in the void setup runs only for once. Okay, I'll just show it to you again. I forgot to tell that, I'm so sorry. So there were two, void setup and void loop. So void setup is like variable initialization. You used to do like, right, int a is equal to 10. So that's how it is. So in this pin mode, I'm setting up my pin mode, that is pin, select the pin that is connected to LED built-in, which is the pin, and that I'm putting it as output. I'm selecting it as output. And this LED built-in, I'm digitally writing it to high. So the point here is, even though I've written it only once, it runs how many ever times that I keep the simulation going, because it's a void loop. So once this statement is executed, it comes back to the first step and starts all over again. So it keeps on running until I tell stop the simulation. It keeps on running. Okay, so this is about how exactly does Arduino IDE codes work. So let's look at the next step. What happens? What did you learn after your print statements in C programming? If statements, right? So that's what we're going to look at. So if this happens, then you have to do this. If this condition is not fulfilled, then don't do this. That's what we did in the LED also, smart LED also. We said if somebody is there, that is, if the sensor crosses the certain threshold, check constantly the sensor value. If it has crossed, then tell the light to turn on. If it has not crossed, then tell the light to turn off, because there's nobody in the room, right? So this is another circuit where you are using a push button to control this LED and this piezo, or like the buzzer. So I'm not going to show you I'm not going to go into the details of the circuit, but I'm definitely going to show you the code, how you programmed it. So some variables I am initializing. Serial begin, this is for serial monitor. When you look at IDE, you can actually see every second output that you can get in the serial monitor. And you are initializing buzzer as output, button pin as input, and LED pin as output. So which means this button is input, buzzer is the output, and LED is also output. So void loop, button state is digitally read to, button state gets the value of digital value of button pin, that is it pushed or not, is it high or not. So why am I doing this? Instead of writing button state here, you could have written the whole thing here Instead of this, you could have written this in place of button state and still it would have worked fine. If you don't know why, do go ask your computer science teacher why you should not do that. It's not a good practice to do it, but there is a specific reason. You can go ask her and she'll be very happy that you asked this question. So why should you not call a function inside an if statement to verify it? So yeah, so if the button state is high, that is if the button is pressed, then you're writing the LED pin to be high and the buzzer plays a certain tone. So that's what we've written. There's no else case. Okay. So if the button is not pressed, what to do? There's no case for that. So we'll start the simulation. Even though the simulation is started, it will not do anything because we're not told what to do if the button is not pressed. If the button is not pressed, the circuit remains idle. Even though it's been 6 seconds since the circuit started, it will not do anything. It will wait for the button pin to go high. So once the button pin goes high, the LED turns on and the buzzer also starts telling a certain tune. Oh, the screen was not shared. Is it visible? Like, is it not visible?
Yeah, it is visible.
Okay. Oh, it was probably there concerned. Do we have to buy these things? Not necessarily. You can do it all like online also, but it's good that if you have an actual project to be done. You guys are very interactive. So see, once, even though the button is pressed, the tune got ended, and that's why it stopped. But still, the button is still high because the LED is still on. And the button, if I press again, it'll again start emitting it. Okay, so you got the concept of how looping works. You got the concept of how if works in Arduino. Even though I understand it's not completely there, but if you go ahead and try out yourself on Tinkercad or any other, you watch another Arduino video as to how to do this, how to connect these circuits, I'm sure you'll get it in a couple of 4 or 5 hours of intense working. Right? So this is what is step 2, right? Where else can you? The problem here is it's just step 2. You don't know what level you can reach with Arduino. You think that, oh, this is so simple and this is so nice. This is not a real life solution, right? What will you do with the push button that will turn on an LED and a piezo or a buzzer, right? You can do that in many ways. Your normal light switch works in this way. So I always had this confusion when I just started learning Arduino. Like, what is the exact use of Arduino? Why is Arduino so important? Why can't I just do an electrical circuit with just the button and a battery, and it works in the same way, right? Why do I want Arduino to constantly check the logical operations? So it just depends on what extent you want to go with Arduino. So suppose, let's take an example. You want to, you come home after your college, you're damn tired, you're done, it was a hot day, you had classes, you're boring, like the subjects that you absolutely hate, you had them, you're done, you did lab, you did not get the output, teacher scolded you, basically you had a terrible day, you come back home, you're lying on your bed watching your favorite YouTube video or watching your favorite Netflix show, and your fan is turned on, but you want it in a higher speed because the temperature increased and it's an afternoon. So you have to get up to change the fan speed. You don't have it right next to you. What would you do? I would just lie down. I'm like, it's okay. I'll die here, but I'm not getting up. So imagine if you could automate this using Arduino in your house. Like if the fan speed was controlled by the temperature of the room, how cool will that be, right? So what do you need to build this? This is fairly simple. So you need an Arduino board, you need a temperature sensor, you need a fan or a DC motor. Fans are ultimately DC motor. The main part of the fan is a DC motor. So that's what we're considering. And an LCD screen just to display what is the value of temperature, what is the fan speed and all of that. Okay, so let's look at the circuit. I'm not going to show you the code. It's a little complicated, but it's basically divided into 3 steps. It welcomes you, then it records the temperature, it changes the fan speed according to the temperature. These are the 3 steps that is involved in it, okay? So let's start the simulation. Okay, before that, let me just tell what are the components that is used. DC motor, and this is a relay because DC motors are not very happy with 5 volts. They need higher voltages. So how does a relay work? They're very, very interesting. Electronic students, I mean, computer science also you learn in your third semester, you have ADE. In that you'll definitely learn. And these are very interesting. Until I learned the concept of op amps and amplifiers, I did not really get the concept of how voltages are changed. And the basic thing that you've learned in thermodynamics is you can't create energy out of thin air, right? You need energy to convert it into energy. So I was always under the impression that voltage is directly somehow related to energy, and you can't produce voltage higher than the previous voltage. And of course, what is that? The big things that you get. I forgot the name, but yeah, those things all obviously told me no, you can produce the DC, the AC power generators and all that. So we learned that electromagnetic waves can generate electricity, right? But this is an entirely different concept. The gain, the voltage, input voltage, output voltage, it's not even related to the electromagnetic waves. It's a very, very interesting topic. You should learn, even though you're barely interested in it, you should learn how relay functions. It's very interesting. So yeah, that's how relay works. It takes a smaller input and amplifies it to a bigger input voltage. So yeah, this is DC motor is connected to relay, and this is temperature sensor, and this is an LCD screen. The LCD screen has a number of pins directly connected to Arduino, and if you understand how each of these work individually, you can put together inside a circuit, right? So that's why learning those components are important to do here. So auto temperature, recording temperature, it's the second step already. It recorded the temperature. It said, okay, I'll set this fan speed. So if I change the temperature, recording temperature, 34.96. Fan is turned on, speed is changed to 40%. If I change it again, let it record. After that, I'll change. So it recorded, I'll change. So just after it recorded, I changed. It did not go back to C because that's the steps of it, right? It records, it welcomes you, records the temperature, changes the fan speed. So that's a disadvantage, right? Here it's a very real-time system, which okay, it's in the delay. It's okay if you have a certain amount of delay, if you have human intervention. But say, suppose you have a drone that you're flying with the help of Arduino, and you realize that you have, I'm audible, right? Yeah, now I think no.
Your voice is a bit breaking. I think some network issue from Pujita's side. Pujita, you're not audible.
Yeah, now it's audible, right? Properly.
Yeah, now it's audible. Please continue.
Sorry for that. I hope you heard until real life systems. Okay, I will just go back to it. So even if your Even if this has a couple of minutes delay, like if your temperature sensor has a couple of minutes delay and you get the fan speed changed after a couple of minutes, it's okay, right? It doesn't matter. Even 5 minutes of delay, it's okay. You don't realize it. But imagine if it's a drone that you're flying and you can't have 1 second delay also, because what happens then if you have a second delay, then even if your drone is imbalanced for a second, by 1 second, your drone can be on the floor, right? So immediately after it detects even in between, it has to detect the imbalance. So it's important to make a trade-off. It's always been a trade-off for every one of us. In life also, and circuits also, everything is a trade-off. You have to trade off between resistors and heat. You have to trade off between power and heat. All of that is always a trade-off. So even in Arduino, it's always a trade-off between how many times you check it and the length of one cycle. So if the one loop cycle is not is too much, then also your circuit is not very efficient. So you should make sure that you land in a certain balance that makes both of you happy. It makes the circuit also happy, makes the user also happy, because the constant checking and all of that is there. So yeah, that's about to what extent you can go with Arduino. So now let's look at some of the examples of what can you build with Arduino. So the first few things, Arduino radar, you can build it using an ultrasonic sensor that detects foreign objects, that detects something when in its path. So this is using the same concept. You can build a blind man's stick. Like you can say that if the object is certain distance, then you will give a certain vibration saying this far it is. And if it's like too close, you will say, okay, you have to like make a sound also so that the user identifies it. If it's a vehicle approaching, then you have to make a certain different noise, because the user has to identify it's a vehicle and move away accordingly, right? So what else can you build with something that you learned today? Smart home automation system. We just saw how temperature sensor can be used to control the fan or the DC motor present in your fan. You can use your voice control to change the light, change lights, change the brightness of the light if it's permissible, and if it's nice, you can use RGB LED to change color. You can use a voice command or use a certain button. You can use your phone. You can connect your Android. There are different applications that are available which you can connect your Android to your Arduino and all of that. And robotic vehicles, something that is very, very nice and very fascinating are robotic vehicles. IIT Kanpur had one of their events in 2018, back in before COVID, way before COVID. And they had two interesting competitions based on Arduino. And one of them was very normal. You had to build like a vehicle that takes an obstacle and runs through the obstacle course. And the second one was very interesting. You had to build a short distance algorithm with point A and point B will be given, and you have grid lines. You had to travel through the grid lines to reach from A to B. You had to find out the shortest algorithm, shortest path. You're not supposed to intervene. The Arduino is supposed to find out where it has to go through and go through those grid lines in order to reach it. It's very interesting to see that all of them, most of them who had come had built it using Arduino itself. And it's very interesting that I did not know so much of Arduino back then. I was not even very, that's when that competition spiked my interests in Arduino, and that's where I've come from. So yeah, so next is drones. Man is always fascinated with flying. Even in like receptions and all, I see drone, I'm like, oh, so cute. And then, so it's something that always we want to build, and it's very fascinating to us. You can build quadcopters with Arduino. Smart bins, again, same concept. With the distance, it opens up the bin, closes the bin. This is the servo motor. You can actually see it has slant line, right? If it goes front, then it kind of puts pressure on the padding, like the paw, and then it opens up. Pulse oximeter, again, COVID third wave is already with us. So if you have had the people who've had symptoms previously and then they're still coping up with the COVID aftershocks, you still need, and for elderly people, you still need a pulse oximeter. You can build on using Arduino. This is a smart street light extension of smart light systems, built by one of the students who's taken up Taika. It's very nice. It looks very nice. So yeah, this next one is a crack detection system. You can detect cracks using ultrasonic sensors. Again, the same concept, distance is measured. When the crack is encountered, the distance changes significantly, and there's a buzzer and the light change that goes on. Buzzer is not audible in the video, but there's a light change and detects the crack that it's a crack. So you can also take up DICA and make real life engineering project. Not just DICA, you can take up any Arduino related course. You can learn Arduino and build this kind of amazing project in with your friends. See, the possibilities are endless. Once you learn Arduino programming, you can create amazing projects with your friends. So there you go. Arduino is not just a development board, but his whole ecosystem that makes it so special, and understanding how to make use of this ecosystem gives you the full power to use Arduino. Ignite your inner passion by building real life projects as a true engineer instead of just degree holders. Thank you so much, guys. If you have any questions, you can drop it in the chat box. I know you have dropped a couple of them. If you have any more questions, you can constantly drop them. Meanwhile, I have another poll for all of you. You can attend that. What kind of projects do you want to build with Arduino? I'll give you a couple of more ideas in the meanwhile also. A couple of them have asked how do you choose between Arduino and Raspberry? Okay, so it depends on your project. For something that you need to store and need a Wi-Fi model for all of your projects, then it's better to use Raspberry Pi. And if it's a much more simpler, if it's a much more simpler project that you want to automate something, you can use it with Arduino. You can build it with Arduino. I think our expert Dheeraj is also here. Dheeraj, if you would like to add something to that, you can add something to it. How will this all help us? Arduino specifically, you can continue Arduino with very extent, right? You can start off with Arduino. You can go with embedded systems after Arduino, and you can learn microcontrollers, different microcontrollers that you can use. And after you learn embedded systems, people do masters in embedded systems. You know, like EC electronics people, they do masters in embedded systems. Embedded systems are mostly computer science hardware, so you can use that. If it depends on what board you want to use, Kundan. I told you development boards can be coded in different languages. It depends on what board you want to use. Again, it all depends on what project you're building in order to use which board. Yes, exactly. No. If you're doing anything with machine learning, it's better to use Raspberry because it has higher power and it's easier for you. But the problem is Raspberry Pi is complicated compared to Arduino. So if it's your first development board, I assume that you already know something. If you already know something about the development boards and you've had previous experience, then definitely you can go with the Raspberry Pi as your first option. But if it's your first thing that you are starting and you're very newbie to this, then definitely start off with Arduino and continue to Raspberry Pi. Yeah, Raspberry Pi is much more expensive than Arduino. That's definitely there. Yeah, that's how will all help us. What is Raspberry Pi? I think I already answered that.
Thank you, Lord. Okay.
Okay, so by then I'll just give you another idea of Arduino. Yeah, exactly. Priyojyoti has told, don't wait for your fifth sem. yeah, I think I don't think not a lot of institutions accept Arduino as your mini project. So it's not ideal to take it up as your mini project um, for your like syllabus, academically syllabus. Definitely learning Arduino and making projects with Arduino adds much more value to your resume. So once you guys have filled that, okay, I have a lot of inputs. That's nice. So I have some another few more ideas also. We'll run out of clean water by 2050. So we have to do something to the clean water, and we have to, farmers are backbone of our Indian society, and we need uh, people to help farmers because farmers are like suiciding constantly in our country, and it's not good sign. And another thing is, that Chrome, when you do not have internet, the dinosaur game comes up. So you can automate that using Arduino. It's very interesting. You all would have heard how to do it with JavaScript command, right? You can do that with Arduino. You can put a sensor that detects the cactus, and you can use a servo motor to make sure it jumps. It's a nice, interesting one. You can actually Google. I think you will get a project of that on like Google. Dheeraj, you here?
Yeah, Pujita, yeah.
I think there are a couple of questions. No, and previously there was one question, ma'am, if the sensor detects only humans. It does not detect only humans. It detects every motion. It doesn't detect like so small insects also, but it detects animals like that. Okay, I think there was a question that said, Arduino. How can I use camera with ESP camera with Arduino, and if possible, imply machine learning based on the input of the camera?
Okay. So, okay. Firstly, Arduino is a microcontroller. So, what will happen is you can't do heavy programming on like machine learning and all on Arduino. For that, you would need a microprocessor so that it will be efficient. However, right now there are many things coming up called tiny ML, so that you can use it in microcontroller, but it is still in development stage. So you can't really use in Arduino right now, as of now, ML or anything. And regarding ESP cam, I believe ESP cam itself is sufficient enough. Since you're asking ESP cam, I guess you know what ESP is, and it can connect to your internet, and then you can use ESP cam as a security camera, maybe an internet security camera. And it is very small also and affordable. That is great. Yes, you can actually connect it to Arduino, but not really sure for what application, but you can connect PSP cam to Arduino.
I think there was one more question, right? Yeah. What is good for gesture control car? Nano?
Yeah, right. So Nano would be sufficient because basically Nano and Uno have the same microcontroller. It is just the form factor is different. The only difference would be in the input. You have a 9-volt jack over there, DC jack, so that you can connect 9-volt battery, so that you can run. That is one advantage of Uno. If you want the project to be portable, I guess it is good. We have small form factor. It will be easy. But if you want to connect 9-volt battery, then again Uno would be better as well. What is the difference between Uno and Mega? So again, microcontrollers are different. Both are having different microcontrollers. Uno has that Mega 328P, and then Mega has 32U4. So there are many additional features also actually. more pins. You have 52 pins in Mega, whereas in Uno it's just 26. So a lot of difference. It depends on application. If you want something which involves more sensors and actuators, then you can use Mega.
I think there was one more question, ma'am. Which programming language is necessary to learn for EC? For electronics and communication, if you really want to continue and grow in like EC specifically, a few important subjects for you will be microcontrollers, embedded systems, and I think you will have a subject called VLSI design also. I don't know if that will come for you as an elective, but if you want to continue in electronics domain and do with those, it's better you learn C programming. And there's something called Verilog HDL also that is also used in VLSI programming and all of that. So you can learn more about them also.
So another question, confused in electronic connection of receivers of gesture controller card. Can you be a little elaborate? I'm not exactly understanding what you needed. Does this help students who are not in CSC and EC? Of course, it all depends on you again. If you have an interest in building something which is helpful for society or whatever it is, maybe IoT, you're interested in it, and then you want to move forward, you can. The domain really doesn't matter. It is just a foundation, you can say. Later on, how you take it up matters. In CSC, I think you would be able to think in terms of how it is applied in hardware. No, so maybe in that sense it might help a little, but it helps in both the ways. It's not specifically domain wise.
Okay, I think those are the questions. Please do fill the feedback form that your organizer has sent.
Okay. Clone and original Arduino. In functionality, there is no difference between clone and original. Only thing is, original is built by the Arduino platform itself. They'll use the actual components and everything, and the board quality is also good. However, in clone, they don't really care of the quality, so they care of functionality. So the ICs and the controller which is capable of doing the same function, they just put it over there and then we'll get it. That's the only difference.
Okay, thank you guys. Yeah, as we previously mentioned, you can learn Arduino in 3 different places. You can definitely start. I would like to tell you that you can start with us in Sapiensary, but definitely it's your wish. You have other options also, YouTube, or you can go learn in open source community of Arduino. So yeah, I hope all of you had fun. Thank you so much.